Okay, I am recording quiz for chapters 4 and 5. Question number 1. Can the value 1 be probability? Yes, the answer is yes, because 1 is representing 100% portion wise. Okay? Question number 2. Which of the following values could be a probability? Excuse me. Could be a probability. So definitely square root of 6 cannot be probability, because square root is going to be 2 point. The probability can be maximum 1 because it's 100%. So it's going to be 1 or below. Cannot be negative, obviously. So 0 point square root of 6, it's over 1. Negative 3, it's negative, cannot be. This one can be because it's approximately 67%. This 11 over 7 cannot be because it's over 1, it's improper fraction. 1 over 6, yes, can be. Checking. Bingo. Question number 3. A 6-sided die is rolled. What's the probability of rolling 1? So there is only 1 times 1, right, on a die. So if it says rolling a 4, rolling a 5, rolling a 1, doesn't matter the value. In statistics, we use a quantity. So how many 1s are there? 1. How many 4s are there on the die? 1 time. How many 5s are there? 1 time. Therefore, all these, the answer for all these questions I just brought up, it's going to be 1 over 6. Okay, bingo. Next. A study asked people many questions about their cars. One question was the reason that a person chooses a given car, and the data is in the table. Okay, safety, reliability, cost, performance, and blah blah blah. Find the probability a person chooses a car for each of the given reason. Round to 4 decimal places. Okay, let me open my calculator so I can fly faster over. Okay, ready. So probability of safety. So to find probability, first of all, we need to find the total, right? Which means I'm adding 74 plus 61 plus 56 plus 53 plus 49 plus 33. So let me see total how many I counted. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I have to check myself because I do silly mistakes a lot. Missing number or type the wrong number. Okay, 326, which means since we are interested in probability for safety, so how much safety we have? 74. Then we are going to take 74 over 326. And I'm getting, since we need to round till 4 decimals, we are getting here 0 point. 4 decimals, it's going to be 2270. Next, reliability. How much is reliability? 61 divided by 326. It's going to be 0.180. 171. Next, cost. How much is our cost? 56 over 326, 1718. 1718. Okay. Next, performance. 53 divided 326. 53 divided by 326. Oh, 53. Hold on. 53 divided by 326. It's gonna be. It doesn't take. Give me some numbers that I don't like. It wrong number. Over 1 for sure. 53 divided by 326. Okay, looks good. It's gonna be 0.1626, rounding at the same time, right? Comfort 49. Okay, 49 divided 326. 0.1503. 0.1503. And looks 33. 33 divided by 326. 326. And we get 0.1012. 0.1012. We have it. So I'm curious which one is highest probability people check for. Safety. Very true. I also look at safety number 1. So the more safety, the better. Second one is cost. No, second one is coming reliability. Yeah, well, safety is and reliability are tied up to each other, right? Okay, let's check the answer. Bingo. Next one. Write the sample space. Gavin is taking 2 of his 4 children to dinner. Okay, we need to find sample space, meaning all possible combination. We need to find all combination of 2. So one version, let's start. It's gonna be Gladys, Bella, right? Next, it's gonna be Gladys, Kylie. Next, it's gonna be Gladys, Zach. Okay, now Bella, Kylie, taking Bella, Kylie combination, then Bella, Zach. Okay, then moving to, Kylie, moving to Kylie, since before Kylie names we have already this combination, so we have left Kylie, Zach. So, okay, how many we have? 1, 2, 3, 4, 5, 6. Okay, we have 6. Now we need to find probability. Gladys and Bella, meaning GB. How many we have here in the sample space? Only 1, right? So it's gonna be, let me see, where is, I need fraction. Let me see. Let me switch it so I can get fraction here, maybe, possibly. Okay, it has to be 1 out of 1, 2, 3, 4, 5, 6. 1 out of 6, right? because we have only one GB, Gladys and Bella, and I just cannot get to this. No, that's not what I want. Well, okay, let me see if we'll take like this. One, where is slash? No, it's not possible. Okay. Trying again this way. Sorry guys. It's a device acting up, or program is not perfect, I would rather think. Let me go through these functions now. ABC. No. Okay. It's not working. But just so you know, it's going to be 1 over 6. So once we get their mistake, we're going to get mistake because I can't type 1 over 6. So, but at least remember, write it down, 1 over 6. Okay? Okay, and next one. Well, all fractions are going to be screwed up. No, it's not working. Forget it. We know that's 1 over 6 when we get mistakes. Now we are rounding. 1 divided by 6, it's going to be 16. It's going to be 0.167, which is going to be 16.7%. 16.7%. Okay, oops. Yeah, correct. So 1 divided by 6, 0.167, that is 16.7%. Now, probability of not Zach. How many we have here? So I'm looking everything that doesn't, in the sample space, everything that doesn't have letters Z, because not Zach. So we have total 1, 2, 3, right? So 3 out of total 6, it's going to be 1/2, right? You know what? I'm going to write down in the decimal notation. Let it catch as a error, but at least you will see the answer. 0.5. Okay, and in percentage wise, it's going to be 50%, correct? Okay, checking the answer now. These two are going to be wrong because it's requiring oh, it accepted. Very good. Then this one also we can put 1 over 6, 0.167. Okay. Let me see the. Okay, yeah, well, that's funny. This C accepted in decimal, but B doesn't accept. But we know it's correct. 1 over 6. Moving to next question. Question number 6. 360 trout in a pond are tested for disease. 32 of them tested positive. So, empirical probability that randomly chosen trout will test positive. So 32 out of 360. 32 out of 360, meaning 32 divided by 360. And we are getting how many decimals we need? Okay, I'm going to put all decimals here because it doesn't say anything. So it's going to be 0.0 and bunch of 8s. 8, 8, 8, 8, 8. Okay, enough. Next. The trout will test negative. Easiest way would be 1 minus 0.08888 because it's a complement, but because it's going to be get approximate value, I'm going to go not effective way. So 360 if it's not test negative. So if 32 test positive, then 360 minus 32, it's gonna be test negative, 328. So to find percentage of negative 328, we divide by 360. Again, the right way would be 1 minus 0.08888, but since I'm not sure if it won't catch as a mistake, if it would be somewhat rounded, then I'm going precise calculation, through precise calculation. So 0.9 and 1. Okay, see, since if I would subtract, I wouldn't get the answer, because after 15 numbers, the 16th is 9. So if you round, you would get last one is 9. Okay, next, let me put here 9 just in case, not to catch mistake. All right, we'll see. Okay, bingo, correct. Number 7, what do we have here? Again, we have here table, total 200 employees, it says in the word problem, and we see here in grand total 200. So that's a magic number we are going to use as a total. Okay, what's the probability that a randomly selected employee did not approve? Okay, where is our did not approve? Here, disapprove, which means we take 82, total of disapprove, 82, it's a column, and we divide by 200 because grand total is 200. And we are getting 0.41. Is not oh, okay, I'm sorry, did not approve, and I'm looking at disapprove. Did not approve, it's gonna be disapprove and indifferent, right? So which means two ways we have: 200 minus approve, eliminating approve, 200 minus 60, it's gonna be 140, or we just add total of disapprove and indifferent, which is gonna be again 140, right? So, and therefore the probability of disapprove is going to be 140. We divide by 200, and we are getting 0.7. Next one, probability that was in the 25 to 40 age group and approved. Okay, 25 and 40, it's a second row, and approve, first row, right? Approve, and we have 21 people of age 25 to 40 that were approved. So we take this 21, it's like intersection in between column of approve and row of 25 to 40. 21 over total 200. And we are getting 0.105. Okay, moving to next one. So was not in the 25, that means we have to eliminate 25 to 40 age, and approve. So we are looking for the column approved, total 60, and out of 60 eliminating 21. So 60 minus 21 is equal 39, and we divide by total 200, dividing by 200, and we are getting 0.195. 195. Okay, if it would say was not in the 25 to 40 age and let's say disapprove, then we will look among disapprove. We will do 82 minus 22. Okay, so whatever column is giving you, you are working with that column. Oh, here it is. We have another one. Was in the 25 to 40 or was indifferent or. So what we are going to do here in this case, so we are going to take, this is or, so we have to take separate probability of 25 to 40, separate probability of indifferent, and because one is a column, the other one is a row, we definitely gonna have the overlapping, so which is gonna be this 12, right? This 12 here between indifferent and 25 and 40. All right, so let's work. First, we are taking 25 to 40 probability. It's going to be 55 over 200. Let me write down. 55 over 200. And then plus, how much is our indifferent column? 58 over 200. And let's subtract the overlapping. How much we said it was? 20, no, 12. Yeah. Minus 12 over 200. Okay, we go easy way since we have denominator the same for all three. So 55 plus 58 and minus 12. And we are getting 101 over 200. So let's divide 101 by 200 and we are getting 0.505. Let's write down. Okay, 0.505. Question E. Find the probability of randomly selected employee that was not in 25 to 40. Let me write down. I copied here picture so we can work here. Otherwise, I can't show there or scratch on the table. So, not 25 to 40 condition and because it says or here it is or was indifferent. Okay, so plus probability of indifferent, and we need to subtract if there is overlapping probability not 25 40 and right overlapping. Every time when you do or, you have to watch for overlapping. If you have column and row, then definitely gonna be overlapping. So let's go for it. Not 25, so if not 25 40, I am taking this off and it will be what? 200 minus 55, right? So 200 minus 55, 145. Yeah. Okay. So we have 145. So probability of not 25 40 is going to be 145 over total 200. Next, probability of indifferent. Our total indifferent is going to be 58 over same 200. Now, remember what I said, we need to watch out overlapping. What is overlapping? Let's say 25 40 is gone, we are not considering. But look here, overlapping this one under 25 indifferent, and overlapping 26 over 45 and indifferent. Therefore, we are going to do minus 20 over 200 and minus 26 over 200. Okay, so what are we going to get? Let's solve it. It's gonna be well, 200 common denominator, so 145 plus 58 minus, well, 46 minus 46, it's going to be 157. So 157 divided by 200, 0.785. 0.785. Okay, next, F was not 20. Actually, we can check even half of it, whatever we answered. Let's check. Okay. No, it doesn't check until. Let me see. Ah, correct. Very good. It checked. Correct. Everything is correct. Moving on. Was not 25 to 40 and did not approve. Let's go for it. Was not 25 and. So we have not 25, 40 and did not approve. Okay, since we have and, we're supposed to take and multiply, right? Probability of not 25 to 40 and multiply by probability not approve, right? That would be in a case if we wouldn't have intersection. Let's say if it would ask probability of disapprove and probability of approve, then we would take 82 over 200 times 60 over 200. But in this case, when we are looking, we have intersection 25 over 40 at 240, it's going horizontally, and probability not approved, it's going vertically. So in this case, we are going to look for the intersection, and that will be the part that will belong and to one event and to another event. In this case, there are two ways to solve this. Not 2540, so it's gonna be left, and that doesn't belong to approved, and 2540, it's gonna be this, right? I can add them up and divide by 200, or more, I would say, more effective or professional way, I would take, since total this 82 of disapproved, and do minus this elimination 22, right? And would get total what we have 60, right? Would get these two yellow shades. And here also, in the case of indifferent, I would eliminate 58 minus 12, because that's 12 belongs to 2540. See, I scratched so I can see. and I would get 46 that way, and then add them up. 60 plus 46, 106. Or you just take, like I said, all these shaded cells, 28 plus 32 plus 20 plus 26. And I assure you, you will get same 106. Once we have this 106, we take this 106 over how much? 200. And this is will be our here 200. And this is gonna be 106 divided by 200. We are getting 0.53. 0.53. Okay, what else we have left here? Next questions. Given that employee was in the over 40 age group, what is the probability that employee disapproved? Okay, we need now given. Remember what I said, when we have given, that's going to be our total, which means, speaking in language of probability, it's going to be what's the percentage of disapproved among over 40 age group. Okay, so let's go see over 40 age and disapproved 32. Here it is. Let me show here. It's over the among disapproved. Disapprove among over 40. I'm sorry. 32 and given over 40. That's always gonna be our total. 32 over 85. Okay. Yeah, 32 over 85. 32 divided by 85, we are getting 0.376. 0.376. Let me show one more time. Here it is, the table, so you can see. All right. Next, was not indifferent. So given employee over 40, what's the probability that was not indifferent? Okay, was not indifferent. Which one is not indifferent? It's gonna be 27 and 32, right? Among these 40, was not indifferent. Was not indifferent meaning I'm scratching this and I will have 27, 32 among 40, above over 40, 85. Okay, so it's going to be 27 plus 32, 15 equal 59, and we're dividing by 85. And we are getting 0.694. 0.694. Okay, next one. What's the probability of selecting an employee? Okay, let's check it first. Bingo, both of them are wrong. Let's see, maybe I'm curious. Jesus Christ, 4 numbers it wants. It didn't say. Did it say us? 4 decimal. Okay. It is my fault. Just round up till 4 decimals. Okay. So we solved correct. Okay. Now here. What's the probability of selecting an employee that was in 25 for the age group from group of employees that approved. See how they put what's the probability selecting an employee that was in the 25-40 age group from a group of employee that approved. Now this from the group, that's from the group become our total, which means amount we need to look amount of probability of 25 to 40 among approved. So approved become total, and we need to find percentage of 25 to 40 among approved. Let's see. 25-40 among approved. It's here, it is 21, 25 to 40 among approved, and since total is approved, we are dividing by 60. So 21 divided by 60, we are getting 0.35. There is no 4 decimals here, so I just put 0.35. And disapprove did not disapprove. Okay, where is disapproved? Did not disapproved, which means we have to eliminate. So we had 25-40, right? Let me double check. Yeah, 25-40 among not disapproved. So we eliminate this. How much it's gonna be? The total 60 plus 58, or 200 minus 60 minus 58. So which is same thing. 60 plus 58 is gonna be our total. 8, 11, and how much we have here? 25-40 among approved is 21, among approved is 12. So 21 plus 12, it's gonna be 33. So we are taking 33 over 118. Let me see. And we are getting 0.2797. 0.2797. Okay, I made sure 4 decimals and rounded. Let's check. Correct. And moving, how many questions we have left? Okay, well, at least every question, only one question asked in every problem. Okay, question number 8. Determine whether the table represents a probability distribution. Well, what we have to do, we need to add this probability of distribution. If it ends up with 1, which is 100%, then it's going to be yes, probability distribution. If it's less or more, then it's not probability distribution. So 0.05, and so 5%, 15% is 20%, 30%, it's going to be 50%, 50%, yes, 100%. It is probability distribution. Next one. Find the mean of probability distribution. Okay, what we are going to do again, meaning we have to take every single x and add and multiply by its probability, which means 0. X is 0, the matching probability of x is 0.2. So 0 times 0.2, this is 0. Next, plus 1 times 0.15, so will be answer 0.15. And then plus 2 times 0.2, it's going to be 0.4. So plus 0.4, adding to 0.15, right? And then 3 times 0.4 45, it's going to be 15, 12, 13, 1.35, adding 1.35 to the sum, previous sum, and we're getting 1.9. 1 point, every time it's bringing different display. Correct. So let me repeat myself. 0 times 0, 2, and then 1 times 0, 15, 2 times 0, 2, 3 times 0, 45, and then add them up. Question number 10. Okay, here we need to find our expected value. Let me take a picture of this word problem so I won't go forth and back. You also can take a picture or write down the data. So that's the last question. Hallelujah. Okay, so a bag contains 1 gold marble, 7 silver marbles, 23 black marbles. Someone offers to play the game. You randomly select 1 marble from the bag. If it is gold, you get $1. If it's silver, no, I'm sorry, you get $3. I underestimated gold. If it's silver, then $2. If it's black, you lose $1. Okay, so probability total, how many we have? 1 plus 7 plus 23. Okay, my writing is horrible. 1 plus 7 plus 23. We are getting 31. So probability of gold, what's the probability? You take 1 ball, it will be gold. 1 out of 31, correct? Okay. Next. Since we get $3, if we win, we multiply by 3. Okay, next we are adding, because $2 for silver is positive. It's going to be 7, silver is 7, 7 over 31, and we multiply by 2. But here we get -1, so we need to subtract, it's a loss. We are getting 23 over 31 and times 1, or you don't even have to times 1. And we are getting 3 over 31 plus 14 over 31 and minus 23 over 31. And we are getting, so 23 minus 3 and 14, 17. We are getting -6, -6 over 31. So if I divide 6 by 31, I'm getting 0.19. Okay. All right, so -0.193548. Well, let's see how much I want to round. Doesn't say anything. Okay, so we put negative. Where is negative sign? My God. Again. Okay, here is fraction, see? When we need it, we couldn't find. Negative 0 point, if I round it, it's going to be negative 0.2. Bingo. So in this problem, looks like you are losing $0.2. Okay, all right. submit and end. Everything is correct. I'm done. I took my quiz. Now it's your time. Oh, 91.1 because these two I didn't round. Remember, till four, I didn't keep 4 digits. So be careful. Read precisely how many digits, so not to lose point. If by some any case you lose point because of rounding, contact me please. Okay. Okay, dokie. Good luck.